Okay, well, thanks everybody. I appreciate having the opportunity to talk to you about a couple projects that I and others have spent a great deal of time on over the last, I guess it's almost been 8 years now. So we finished one of these. That's the pilot project in West Union, Iowa. And the other project I'll talk about, and I'm probably going to jump back and forth between the two, is a new streetscape project that's just in the middle of design down in Bloomfield, also in Iowa. I'm a landscape architect. I've been with Conservation Design Forum a little over 8 years, and I do a wide variety of projects here at CDF. We do tend to specialize in water-centric designs and projects that have a strong sustainable focus. But the range of work we do goes from streetscapes to commercial developments. I actually worked on the King Pavilion there at Iowa State. And I don't know, maybe you guys are, no, it doesn't look like you're in the King Pavilion, so you're probably in the old College of Design. Julia, can you still hear me okay?
I can hear you.
Nod if you can hear me.
Yeah, but
I see your face.
But can you hear me now?
She should be.
Okay. What we're seeing on the screen is your actual desktop on your computer. And I wonder, because the image is smaller, I wonder if you can do a full screen on the slide so the students see a bigger image on our screen.
Yeah, there you go.
Yeah. Shoot.
Yeah, there you go. If you go to the next one over, click on that.
Yeah, for some reason it's putting it into presentation mode. It may be because I have 2 monitors open, so let me turn one off.
Okay.
Let's see if that fixes it.
Okay.
Okay. Sorry about that.
That's all right.
Is that better?
That's better. Thank you.
Great. Okay. Yeah, for some reason I'm unfamiliar with the presenter slide it was giving me, and I couldn't move it over to my other monitor. So this will work. So the streetscape projects are great because they really do require full attention to all facets of design. You know, it's work in the public realm, and unlike say a residential building or commercial building, you have a multitude of users. So streetscapes really do require collaborative effort, and that can be challenging, and it's also, it's also very rewarding. The scopes of the 2 projects are represented here. The streets that we improved in West Union, there were 6 of them, 6 blocks. Or actually roughly about 5 blocks, I guess. This is the Fayette County Courthouse building. If anybody's been to West Union, it's a beautiful old building situated out on a hilltop. And there's actually quite a bit of grade change in West Union, which played a factor in how we addressed the design. The county seat was situated on top of this hill, which was a glacial moraine. The 6 streets that we improved go right through the heart of downtown West Union. It's a small town of 2,000 people. In that respect, it's very similar to our new project in Bloomfield, which is over on the right side of the screen, also a county seat. This is for Davis County. And the streets that we're looking to improve ring the courthouse. And for that project, it also includes a little bit of State Highway 63. So that adds a bit of fun to the project and coordinating with the DOT, which actually is turning out to be a pretty good partnership there. So those are the scopes of the 2 projects. I'm going to touch on 4 items today and how they relate to these 2 streetscape projects. The first being the importance of collaboration. The second, I've got the second and the third switched around just to make sure everybody stays awake. Sorry about that. Second, on here it says innovation, but I think we'll touch on sustainability second. The third will be innovation, and then design. So how we actually execute the ideas. Collaboration is mostly how we set the process forward, and how we decide and make decisions. Sustainability really relates to those underlying principles of what we're trying to achieve and what our goals are. Innovation is kind of obvious, and then design is execution. So there are many ways to look at projects, and with a project as big as these streetscapes, I struggle with how to compartmentalize it a little bit, but this is how we're going to do it for today. If I'm on another webinar in the future, maybe we'll split it up a different way. So collaboration, I don't know how much you guys get to do in team projects, but I can't stress how critical that's been for me in my professional career, because there really is no individual, there are no individual designs. And in order to survive a big project like this and have it be successful, you really have to have faith in a collaborative design process. So a lot of times that means letting go of notions that you might have, and that was the case for me with the streetscapes. It also means appreciating and inviting others to participate and help build the design. So for West Union, we started by gathering our group of designers, and it was a broad net. So certainly that includes the design professionals. This is one of the early meetings in West Union, and the gentleman in the green shirt at the back co-managed this project with me. That's John Biederman with TKIP Engineering. He was our local civil engineer. The team also included specialists in geothermal, heating and cooling, so mechanical engineers. We also had electrical engineers, surveyors. On our end at CDF, we had botanists and ecologists. And the role that the design professional really plays in a big project like this is certainly providing objective expertise, but also being a guide for the owner. And I found that different clients have different experience levels with construction projects. And I don't know if anybody's ever hired anybody to renovate their bathroom or do any kind of construction project, but it can be a scary and kind of shocking experience. And I found when you are dealing with constructing somebody else's space, it's as important to realize that you're in that role of guiding them through the process. So letting them know how things unfold. So very early on, we took it slow, maybe too slow. This is back in 2006, I believe. And we did some visioning exercises. So just very soft, like let's bring everybody together in a room and talk about our hopes and dreams and get an idea of what scope of work we're interested in doing and who we should be reaching out to at different partnership levels. And some of the important people locally, it'd be nice to say we had one client, but like I said, with the streetscape project, you have a lot of users, and that means you really have a lot of clients. And so early on, just establishing kind of the hierarchy of who makes decisions, who's present at the meetings, that takes up a lot of time. It's not very interesting, and I know we haven't gotten to any design yet, so bear with me. But on the owner's end, our direct client was the Main Street organization. So they spearheaded this, and they're present in this picture. They represented the downtown businesses. So they were the most direct users of the space, the people that actually live and work right on the streets that we're rebuilding. But the streets are owned by the city, so the city of Bloomfield was also represented, and there were others too, other local interests. Let's see. So here's a slide this is for our Bloomfield project, but it gives you an idea of all the people we're reaching out to at this stage of design for Bloomfield. So again, with Bloomfield, we had a Main Street organization, so that's just representing the downtown businesses. Historic preservation. In both projects, we had the courthouse and the county supervisors to coordinate with. Schools. Other important local representatives are, in this slide you see down here, the Fox River Ecosystem Development Board. That's the watershed review board. In the state of Iowa, you can formalize your watershed boards. I don't believe the Fox River has a formal board. So the Fox River is the river that Bloomfield drains down into, and the Fox River flows to the south and eventually down into Missouri. For the West Union project in the northeast part of the state, the waters all drain to the Turkey River. And the Turkey River is very important from both an environmental and tourism standpoint. A lot of cold water trout fishing up there. So if anybody likes to fish, maybe you've been there, I don't know. It's beautiful though. It's really, really gorgeous part of the state. But for West Union, we did coordinate early on with the watershed, the Turkey River watershed. I'm blanking on the exact name, but and they were an important partner. This is showing the diversity of the state and regional partners. So Iowa Department of Transportation, Economic Development Authority. For West Union, the most important partner we really had was the Iowa Economic Development Authority, and Jeff Geertz spearheaded that pilot project. So West Union was one of 2 Green Street pilot projects. So the Iowa Department of Economic, well, it used to be called the Iowa Department of Economic Development, so I might interchange those. It's now called Iowa Economic Development Authority. They prepared and have and maintain a Green Streets criteria list that they use to encourage sustainable development throughout the state. And the way they encourage it is they tie funding to adherence to the Green Streets criteria. And we assisted in developing the criteria with the Economic Development Authority, and then the pilot projects, one of which was West Union, basically employed those criteria. So I'll try and move through because I know want to get to design, and this is a lot of background. But the background is very important. It's the foundation, or this early stuff is the foundation to your design, and your designs will only be as good as the foundation. So the thing to remember is create a decision-making structure to resolve conflicts and build consensus. So you need something rational. We often jump to our intuition as designers, and that's good, but we need to communicate that intuition to others, and they need to be brought along in the decision-making process. So having a formal structure is important. For both projects, that meant establishing a vision and goals. We like to call our goals first principles, and I'm not really sure why. They mean pretty much the same. But a goal is something you may or may not reach. A first principle, I think, is something that you always adhere to. So the vision, and this is for Bloomfield, the vision is to develop a long-term vision and action plan for the town's public space and infrastructure through engaging the community so that the downtown district sustains and best serves the people of Bloomfield over time. So ambitious and pretty easy to get behind. We then broke that down, and we did this after having a series of community meetings and meeting with various people and interviewing them locally about what they wanted to see with their new streetscape. And then we broke that down into these first principles. So when we asked people, what do you want the new streetscape to do, there were several things under the sustainable category. They wanted it to sustain over time, and you can see the objectives below. They wanted it to be planned, reconstructed, and maintained to last the next 100 years and beyond. That's a really important principle. You don't want to be building something that's going to collapse in a couple years. They wanted the street, sidewalks, lighting, and amenities to support the shops and restaurants in the downtown district. So that's important too. It's got to serve the people right there, and they have specific needs for deliveries and for parking. They wanted it to be beautiful, have well-crafted elements with high-quality materials to ensure durability with minimal maintenance effort and expense. So it's got to be practical. They wanted high-performance green infrastructure that provides multiple benefits, including flood attenuation, improved water quality, energy efficiency, and reduced expenses associated with long-term maintenance and replacement. So they wanted it to be forward-thinking. They didn't want off-the-shelf technologies. They wanted it to be a little progressive. And that's the case for both these projects. The second big category is accessibility. I may just glance through these, and if we have questions, you can ask me at the end of this. But accessibility is important for both. Both towns are over 100 years old, and the sidewalks show it. One of the big situations in both towns, and this is really interesting, is that there are abandoned coal chutes below the sidewalks. So they used to heat all the buildings with coal, and the way they got the coal into the basement is with an open chute in the sidewalk. And they literally pull the wagon up and dump the coal, I imagine, down the chute into the basement. None of these buildings at either project are heated by coal anymore, and those chutes have been filled in and blocked over. But that's been done over time, and so there's been no consistency to how well they've been filled back in. And in many cases, we found logs and other organic debris used as fill, which you may know, disintegrates over time and oxidizes, so it collapses. And the sidewalks are just battered up and settling and not the least bit accessible. Sorry, I've got a touchy keypad here. Next big category was welcoming. Next is charming. Both streetscapes have a strong historic character, and that played a big role. Practical. The point of these first principles, and I'm not going to read every single one because there's a lot we could talk about in each one, and we want to get to the design, but the point is to establish something that legitimizes the ideas you come up with. And that's really important because you don't want to be coming up with something out of thin air. And you need to justify it. You need to justify it to a big group of people. So it's not just you and your client sitting in a back room designing and then it gets built. You've got to, for West Union, we probably had over 30 public meetings. And to be able to respond when someone says, why are you using porous paving? That's a ridiculous idea. Well, it supports these objectives which support these first principles. So you have to tie the solutions back to the goals. And I know that's something I practiced in school and then forgot, and then I rediscovered when I needed it, and I got in a meeting and someone asked me why I was using something and I never had a good answer for them, and I learned the hard way, I guess. So this is how we did it for these two projects. Educational, especially for West Union, the goal of that project is to be an example for others. And so carrying on and teaching others what's being done was important. So that revealed itself with like signage and other ways to interpret the technologies. The other big lesson of the collaborative process is I think something I've learned, and I do tend to get carried away with some ideas I have, and I think they're great, and it's important not to fall in love with your ideas, and like I said before, focus on the principles and not the strategies. And I spelled principles wrong, sorry. That should be principles with a P-L-E-S. So don't fall in love with your spelling either, I suppose. But an example I'll give is we come up with for West Union, we came up with a bunch of great ideas. And if we came up with 100 great ideas, we probably actually implemented 60. And one great idea we came up with that we did not use is this one. And it's back-in angled parking. So back-in angled parking, I don't know if anybody's ever been to a lot that uses back-in angled parking, and it seems a bit funny, but it really supports this idea of complete streets. So I'll get to the idea in a little bit, but the idea you're sharing the street with a variety of users, including pedestrians and cyclists, and a problem that cyclists have in a dense urban environment, and if any of you are cyclists, you may know, is that with angled parking, there's a very shallow view angle for somebody backing out of an angled stall. And generally, you can't see until you're out in the aisle. So back-in angled parking is a way to make the street safer for bicyclists because as you are pulling out, you have a much better view of oncoming traffic in your lane. So we really wanted to encourage cyclists to enter downtown Bloomfield. I think Jeff Geertz, who I mentioned was with the IEDA, is really passionate about cycling, and so he first promoted this idea, but the residents and the business owners were very skeptical. And there were a lot of cries, well, how's my grandmother going to pull out, and how's she going to back in, and how's this going to work? And I had to admit I was a little skeptical too. I'd never seen it. It actually works really well. So in the future, if you guys are trying to encourage cyclists into an urban area and you already have angled parking, I think it's an idea you should consider. You back in just like you would back in to any stall, so that does take some talent, I suppose, but you have a full view of the traffic in the street as you're backing up, and then a full view as you pull out. So once you're in the stall, it works really well. But we got a lot of pushback on the idea, and so for this idea, we tested it, and everybody agreed that we shouldn't throw it out right away, and the city director of public works agreed to stripe 10 stalls in front of the courthouse, and they would try it out for a month. And they did it, and then we surveyed the downtown business owners because we felt they were the most important group. They were the ones who would be most affected by parking issues. And the survey came back, and we did it online, and we were being very transparent about it, and it was overwhelmingly against back-in angled parking. So I was very disappointed, but then I remembered not to get carried away with my ideas, and we moved on. Another important thing that shaped the design decisions is how they're maintained and stewarded. And you really need to think about the life after construction for everything you do because, like I said earlier, if it falls apart right after you build it, it's not worth much. And you won't be able to take your kids there and say, hey, I built this. So. For West Union, something I wasn't expecting is snow removal. And I think Ames gets a good deal of snow. I'm in Chicago right now, and I think neither one of us can brag over the other. I've been to Ames a lot. You guys get about the same amount of snow. But West Union, they definitely, I will say, get more snow than Ames or Chicago. And they get deep freezing too. The frost depth goes down pretty far. This is the snowblower. This is an industrial snowblower that they use to clear the streets. I'd never seen anything like this. I think around here we just salt everything to death and let it drain into our rivers. But here in West Union, they furrow it into the center of the street. So we needed a median, a level median, to pile all the snow up because this machine gets hooked onto the front of a big dump truck and gets pushed down the street, and all that snow, here you go, gets, or I guess it's pulled behind a tractor. I take that back. But this is it in operation, December of 2009. So there you go. So snow removal turned out to be a much bigger driver of design than I think I would have liked it to be. Like I said, we had to have a center median to pile up this snow, and we also needed to accommodate the turning of a plow. But I did do a little snow plowing when I just graduated college for maybe 2 years, and so I do have an appreciation of what it means to plow snow. A lot of times the drivers are doing it in the middle of the night, so visibility is really poor, or they're doing it in the middle of a snowstorm, and plows can really wreak havoc on streetscape environments. So plantings and trees and curbs, that steel plow blade is pretty unforgiving to all of those. So I'll show you how we accommodated it in our design. Okay, the next thing I'll just touch on briefly is sustainability. So we're finished with the idea of collaboration, and I'll move on to the importance of sustainability in the design process. So I'm hoping you guys are familiar with a lot of these issues. I think of sustainability as the importance of two things. And the first is protecting shared resources. So, you know, without sustainability in mind, you can build your parking lot and do it as cheaply as you can to hold as many cars as possible, because that's going to most directly affect your bottom line. So our goal as designers is to remind our clients that there is a less direct way that it affects them, and one and that they have a responsibility over shared resources. So things that not just one person pays for. So I'm sure you guys are familiar with this idea. I think there's both natural and cultural resources. The natural ones certainly are air quality, emission of greenhouse gases. This project reduced overall emissions of greenhouse gases. This project added vegetation, which helps to clean and oxygenate the air and reduce, at least in Chicago, reduce issues like urban heat island effects, so smog production. Water quality issues were a big part of the West Union and the Bloomfield design. So finding ways to discharge our water if we have to discharge it, if we can't infiltrate it all, but to replicate the historic hydrology of the site. So most of, probably all of Iowa was once tall grass prairie, and very little water actually sheeted off the surface of tall grass prairie. The capacity of that soil and vegetation to absorb that water was enormous. And a lot of the flooding issues that have occurred in Iowa are directly related to the conversion of that natural prairie, both for agriculture and the tilling of the soil, but also urbanization around the cities and the increase of impervious surface. So we recognized what our project site was contributing to water quality issues. Like I mentioned, the Turkey River's downstream. We drain directly in West Union into 2 creeks that drain into the Turkey River, but it's an important resource for trout and the fishing industry that the trout support. And trout are very picky. They like cold water to breed in, and the problem with parking lots made of asphalt is the water heats up as it runs across that surface. It collects a lot of pollutants, and those collect in the waterway. So hot water holds less suspended oxygen than cold water. Hot water, and then the turbidity of that water, because it's got a lot of suspended sediments, the algae blooms that happen because there's a lot of excess nutrients like potassium and nitrogen. So water quality issues were big. Soil issues. I meant to mention at the beginning of this that if you didn't know, I'll tell you that the Sustainable Sites Initiative is about to begin its open enrollment period. So moving forward, we're going to have a really good self-applying awards program available for site development. So LEED has been great so far, but a lot of really just focused for building projects that have a site. The Sites Initiative will have will strictly be focused on site development. And I've taken a look at the guidelines, and a couple of our partners have participated in the construction of the water quality credits and guidelines. But I know also they have a very good section on soil protection and soil health. Our projects are both in relatively urban areas, and the soil is not native soil. It's been disturbed. So we didn't have as big a soil protection. Soil protection wasn't as big a part of the design as it might otherwise be, but it's certainly an important natural resource. But returning soil to a historic state was something we were interested in doing, and increasing the amount of plantable soil, and then open space. So that's it on natural resources. This is the, oh shoot, I'm not sure. This is near West Union. I'm not sure which creek this is. It might be Otter Creek. This is not West Union at all. That's Cedar Rapids, and I believe that's in 2008. Hopefully none of you lived near this picture in 2008. If you did, you know exactly what happened. Massive flooding that year. This is West Union. This is Otter Creek, and this is where the city discharges. So that's a lovely picture. Isn't that lovely? You know, hopefully we can do a better job of connecting our urban infrastructure hydraulically to our natural waterways, because this just tells the story in a nutshell of the type of water and the quality leaving the site. And so for us, we always try to expose the path of water so that people don't forget about it. It's easy to forget it when it's in a pipe like this behind a, this is actually the Department of Public Works yard for the city of the city of West Union. But the Watershed Board had done some studies, and upstream is this direction, up yonder, and downstream is down towards the bottom of the page. The water quality, they had measured both upstream and downstream of West Union, and it went down considerably right at this point, which wasn't surprising. But it was helpful to have that report and that study, because we could then create a case for state agencies to fund some of our stormwater improvement strategies, such as bioretention and porous unit paving, because we could show that it would make a direct impact on the quality of water downstream from this point. So we had a baseline, basically. Okay, oh, this says natural resources. It's supposed to say cultural resources, but shared resources are not just natural resources, is my point with this slide. There's also cultural contributions. So civic events, our streetscapes support civic events, and the historical context of the courthouse buildings were important. One second while I take a sip of water. So this is West Union back in about 1908. And many of these same buildings are here. You'll see some pictures of this building on the right. I'm not showing this for this reason, but I think it's interesting that there's a light pole in the middle of the street. So at the center of their intersection, they had these light poles. But it originally was a dirt street. Oh, and I'm showing this just some of the civic events that happen in downtown West Union. this is before we did our streetscape project. But we were interested in using the new streetscape to accommodate all kinds of events and public activities. Okay, sustainability. This is the second notion of sustainability. It really needs to also include financial sustainability. So you've got to put your money hat on, and some of us are better at that than others. I actually like spreadsheets, so this is something I enjoy doing. But thinking how you know, the project is going to impact the financial well-being of the users down the road. So it really means making sure that the long-term life cycle costs are as important as the upfront capital costs, because all your clients are going to want to talk about how much is it going to cost to construct, but not many of them are going to ask you how much is it going to cost to maintain and what will I spend over the life of this project. And to be honest, that's where the money is. West Union's upfront cost was about $7 million, so that's, you know, that's a lot of money. But over the next 50 years, they'll probably spend, you know, 10 times that in maintenance if you consider inflation. So the maintenance and long-term costs are really almost always eclipse the upfront costs. And when you start to think about it that way, you can justify more expensive capital costs. So porous unit paving, the block paving with the joints in between that allow water to go and infiltrate into the ground. The porous unit paving is a more expensive paving system than asphalt. So if you only consider capital costs, you probably would never use it, or you might never use it. But when you consider the repair and replacement that asphalt surfaces have to undergo, we found by looking at several other studies and talking to our clients that have installed these, there's about a 15-year payback. So in other words, after 15 years, the accrued costs even out. And since a porous unit paving system will last at least 30, if not 35, then there's some systems in place that have lasted 50 years. You'll recoup your investment and then some. So looking at life cycle costs also helps to validate some of these improvements. Also LED lighting, that was another big one for us. Replacing all the light poles in downtown West Union cost maybe around $800,000, but there is a savings on the back end for deferred energy use. So that was just a little bit of an analysis. Also, it's important to be realistic. So we started our plan with bump outs and rain gardens all over the place. You know, we love plants. We wanted to put plants in everywhere. But plants need to be maintained, and there wasn't a history of maintaining this type of planting in downtown West Union. I mean, the practicality of it was that the city just didn't have the expertise. And we tried to find the expertise. There is a garden club, and we engaged them. But at the end of the day, we were really worried we'd put in all these plants and they'd become a weedy mess. And one of the big concerns we had was irrigation. Because even though we use drought-tolerant plants, we know that they can experience periods of drought. And in order to protect your investment, you really want to make sure there's a water source nearby if it's needed. So even if you've got, you know, the most drought-tolerant plantings. Now larger reconstructions of prairies and natural areas can kind of weather droughts, and when you have, you know, if you don't have high expectations about how nice they look, you can kind of get away without having any permanent water. But in a downtown streetscape environment where you're going to have routine trampling, you're going to have snow loads, salt, and there are very small pockets of planting, so you lose a couple plants and, you know, that's it. We wanted to make sure there was enough water. So this little narrative walks you through something we talked to our client about, which was we looked at the historical rainfall data for, actually we looked for where you guys are in Ames, and we used that to predict how much water they would have to apply on average. And West Union has a watering truck that they had access to, and so we wanted to make sure that their volunteers could water all the plants. And we actually ended up reducing the amount of plantings based on this analysis because we didn't feel originally that that they'd be able to reach all the plantings and support them. And we ended up having the same volume of bioretention, but as you'll see in the later slides, not all of it was covered in planting. Some of it was covered in gravel to emulate a dry riverbed. So that's what we chose to do, reduce it. Okay, next thing I'll talk about, and then we'll be getting into some strategies here, is innovation. So this is downtown West Union after we constructed it. This is pretty much the heart of downtown, the intersection of Vine and Elm Streets. You'll see a bunch of things being used here. Porous unit paving is used in the sidewalks and in the street. We have bioretention at the bump outs, and there's also smaller bioretention planters in the sidewalk. The majority of rainwater in a regular small 2-inch rain event is going to go straight through the pavers and collect in the gravel below the pavers. It is detained for a period of time, so there is some infiltration, but you don't get to choose the infiltration rates of your underlying soils. You're pretty much stuck with whatever you find down there. And in this case, we have a lot of heavy clay soils. So water does eventually leave our site. Most of it does. But we slow it down and we hold it back so that we are not contributing to the surges of quickly released storm water into Otter Creek and the Turkey River. The gravel also does a couple other things. It filters sediments from the water, and it cools the water. So this is really important because the water stored underground, it doesn't have a chance to heat up. The majority of the paving here is lightly colored, so it has a high albedo or reflectance index. So unlike asphalt, it's not heating up by the sun in the middle of summer, and then when you have a rainfall event, the water's running across asphalt that might be 120 degrees. Stays much cooler. So I think the lesson I'd say with innovation is don't be afraid of things that are new and have never been done before. There's plenty of things I haven't done yet that I'm hoping I get a chance to do. The key is in acknowledging the risks of doing the new things, but also acknowledging the risk of doing things the old way. So that's what this says here. You got to weigh both practices. There's certainly risks in doing porous unit paving in a historic downtown street right up to buildings that are over 100 years old. And one of the biggest risks is that you are storing and detaining potentially millions of gallons of water right up against buildings that weren't designed to have a big detention basin in front of them. So that's something we had to wrestle with and contend with. The solution for us was to install an impermeable liner under the sidewalks so that we could protect those old building foundations. All those buildings that you see here, I'll go back, have basements, and almost all of them are constructed on top of old limestone block foundations. So, so very sensitive buildings, and we also have a great deal of grade change. It may not be easy to tell here, but there's over 5 feet of change from up here down to the very south end of Vine Street. So that provided that made for some technical challenges in using the porous unit paving too, which I can get into in a bit. But the alternatives to the porous unit paving also have risks. So the traditional method of design and what was here before was asphalt. Oh, I'm sorry, someone's paging me. Hopefully that won't interrupt this. But asphalt and concrete sidewalks, and when we compared the risks of all the systems, this was the best strategy we felt for achieving the goals that we had for water quality, but also for financial sustainability, also for beauty and aesthetics. Porous unit paving, you know, is a flexible system as opposed to a rigid paving system. See if I can move on. And it's something I like to call multi-purpose infrastructure. It's infrastructure that serves more than one purpose. So what's great about porous unit paving is, yes, it costs more, but it's also providing a stormwater function, and it can offset costs of a traditional storm sewer system. That should be pretty obvious. So here's the little educational display we produced for West Union. You can see a little cross-section there in the middle, and then the profile of what the porous unit paving system looks like. This is half of a brick cut in half, rather. And then there's a setting bed of smaller aggregate that sits on a larger bed of 3/4-inch stone. And in West Union, and I hope everybody's still with me, but this I think is pretty interesting. There's over 5 feet of this stone under the streets. Mostly that was because how we drained the street in cross-section. So when you have porous pavements, you're really dealing with 2 different grading plans. You got your surface grading, and that all has to work. So everything has to still drain at the surface, because if your permeable paving gets clogged, still needs to sheet and not collect. So you have that grading plan. Then you've got your subsurface grading plan, and you can kind of see in this cross-section there's a reverse pitch under the street. So that was another way we protected the buildings along the side, was by pitching the subgrade to the middle of the street. But pitching it to the middle of the street and having a crown on the street means that the depth of stone in the center of the street is much deeper. And at West Union, we approached the design of this by setting the minimum stone depth that we were comfortable with under the curb. We needed the stone both for storing stormwater, but since it's multi-purpose infrastructure, it's also the structural component of the paving system. It carries the load from the trucks driving down the street. And for that reason, it had to be a minimum thickness. And the soils reports that we had showed that these soils were real sloppy. So a lot of soft clay. And for that reason, we had 2.5 feet of stone under the curb. And that just deepened as you get to the center of the street. So what's great about porous unit paving is the technology. The flexible paving and unit paving is an old technology. I mean, there's brick streets everywhere. This unit paving that we're using, the porous unit paving, is a precast concrete product. I see it's already 5, so I'm going to have to move through these things pretty quick. This is a picture showing it mechanically laid. So this is the innovation of mechanically laid pavers. They literally pick up this whole pallet and drop it down has greatly reduced the cost of these paving systems. This is showing kind of the choice of pavers in the street. So this is West Union, and the street permeable paving was a product called Eco Optilock, a much better interlocking paver for vehicular use. There was a prettier paver that didn't interlock as well and had smaller joints, which was better for women in heels and people using walkers and canes. We use that in the sidewalk. It's Eco Priora. And then I mentioned we had bioretention areas. So this is showing you where those bioretention areas were. And another cross-section through West Union. This is the cross-section through Bloomfield, and we've evolved our design somewhat for our newer project. One of the things we want to do is connect the soil in the bioretention to subgrade. We want to maintain that hydraulic connection between subgrade and the planting soils. It keeps temperatures consistent, it keeps moisture levels consistent. If you look at the West Union detail, we had it all underdrained by gravel. And we've evolved that design here. It also helps us to minimize the excavation, because the haul-off cost and the excavation cost are probably accounted for maybe 10% of the total project cost. So it's not an insubstantial cost. And in this design, the water that moves into the bioretention drains out through the amended soils, which are not natural topsoils. They're a mixture of compost and sand. And it's important to point out that the type of organic material we're using with the compost does oxidize pretty quickly, and so it probably needs to be replenished every 3 or 4 years with fresh compost. But topsoils just vary all over the place, and with bioretention you have to be very careful that you don't have too much clay in the soil. We did the bioretention just to the south of you guys at the Biorenewables Laboratory, and when we did that rain garden, we used topsoil and there was too much clay, and they drove on it and it sealed off. So the clay literally pressed into itself, and we had to remove all of it and replace it. So now we pretty much go with a sand compost mix. And what's interesting is this is very similar to what's used in tee boxes and greens in golf courses. So little did I know I'd have something to learn from golf course design, but there you have it. This is what the construction looked like. So a lot of stone. You know, for us, everything had stone under it. The whole street is one giant detention basin. Okay, some other new things in terms of innovation, using old technology but on a new scale. So LED lights have been around for a long time, but you guys know that you almost can't get incandescent bulbs anymore. LED lights are solid state, so it's not a gas, it's an actual crystal or diode that's energized and emits the light. So it has different light qualities. You can see in this image on top are the old polluting sulfur, I think these are, high pressure sodium lights. And they're just really indiscriminate lights. They spill out everywhere. The LEDs are a lot more directional, which is both good and bad. We had to deal with glare issues at West Union and make sure that we distributed them correctly so we didn't have too much glare. But the quality of the LED lights was much better in terms of whiter light, which is important in retail environments. So LEDs are the way to go. The other cool thing at West Union is there is a district-wide geothermal heating and cooling system. So when you rip up a street, you really have a chance to reimagine how your public utilities are laid out. And geothermal is an old technology. It basically uses the earth as a heat sink and a heat source. So in the winter, we grab the heat because the soil 300 feet down is consistent 54, 56 degrees. We grab that extra heat and we bring it to the surface, and using heat pumps, and I don't know exactly how the heat pumps work, but kind of like your refrigerator coils, transfers the heat into your house. And in the summer we do the opposite. So a lot of you may have or have seen geothermal systems for individual buildings, and this is the same thing. It just says, what if we did it on a district-wide basis? And the advantage of a district is that some buildings are just naturally heat producing. So things like hospitals or schools that have a lot of people in them at one time, all that heat builds up, and you can use that in the winter and share it. Other buildings like supermarkets are cool producing. You know, they got a lot of cooling units in there. So we built a district-wide system. We have 200 wells, geothermal wells, in the courthouse grounds, and we have a piping network. This is a diagram kind of showing how that heat is exchanged in the building. And we're looking at doing that in Bloomfield too. So this is what the system in Bloomfield might look like. This is West Union. These are the wells going in. You don't see anything on the surface after it's built because the wells are 8 feet below the ground. So, and very little disrupts them. Thankfully, this was covered up. That's kind of an ugly-looking octopusy thing, but that's the manifold. This is what's collecting all of the lines from the well field, and then there are pumps in the basement of the courthouse building. So I'm sorry, I know I'm going a little over, so I want to rush through these last few slides. New technology, West Union. Something we looked at doing but didn't employ was a snowmelt system. De-icing agents like calcium chloride or sodium chloride are the DNR listed sodium chloride as one of the biggest pollutants for northeast Iowa streams and rivers. But it's just it's extremely water soluble, and it's very harmful. Chlorides in general are very harmful to aquatic life. So it's a de-icing system was considered. Since we were already doing the geothermal heating and cooling, we thought, could we piggyback it with a radiant tube system that would sit just below the pavers. This is a picture of Holland, Michigan. Holland has a nuclear power plant that has a lot of waste heat nearby, so they actually pipe that waste heat under their streets. We didn't end up doing this. We had a lot of opposition to this idea. The cost was very high for maintenance. We couldn't justify it from that standpoint. And it was a political year, and it turned out what we were calling a de-icing system, the opposition called heated streets, or it turned into something that made it sound like a luxury as opposed to the water quality benefit we were actually going after and the safety benefit. So it was roundly rejected, and I think we're even responsible for there being a law passed in the state of Iowa that you cannot use community development block grant funds for anything that has a snowmelt system. So you have us to thank for that. Sorry. Still a good idea. Also electric car charging stations, alternative energy. The importance of green. Providing a place for plants to live in a streetscape environment is challenging. This is a diagram from Cornell Structural Soil Catalog. Cornell soil is one type of structural soil. The basic idea is providing pore space in and under sidewalks and streets that can serve. So it's a good multi-purpose technology because you're providing place for plant roots. We did not end up using this because we had our porous paving technology, and we were pretty confident that the gravel pore space was sufficient. We did consider, though, the ratio that I think James Urban has popularized of the soil volume to tree canopy. I think it's a ratio of 1 cubic foot for every 2.5 feet diameter of tree canopy that you want to have. So that's a good kind of metric to remember. This is the diagram. This is the signage that we use for our bioretention. Like I mentioned before, we had two types. This is the Parkway planter. It was mostly receiving excess water from the sidewalk, and that was then discharging through the soil and through the gravel into the street. And that's a picture of the completed one. And you see it's treeless because it's not very big in terms of soil volume. We didn't feel like we had enough plantable space to support a lot of trees. And then this is the other type of bioretention. This is at the street level, and these are bump outs. And you can see how the water is conveyed through them, allowed to infiltrate, and excess water drains laterally into the gravel. And this is what one of those bump outs looked like. Okay, design. Return of the pedestrian. So the idea of complete streets, which hopefully you've been exposed to, the idea that our streets should be designed for all different types of users. We've really neglected pedestrians, I think, over the last 50 or so years. I think the rise of the automobile kind of was not anything people expected, and for that reason we have a lot of poorly designed urban spaces that are really uncomfortable to walk around. So we wanted to do better here. This is Bloomfield. This is just showing in downtown Bloomfield there are actually no crosswalks to the historic courthouse. And the crosswalks that do exist in the other places at pretty long distances. And so there we looked at a number of strategies, and these are pictures of West Union, to improve the walking atmosphere. So we added mid-block crossings. We added these bump outs, which, as you can see on the image in the right, shorten the distance of the crosswalk. And we also have a novel arrangement of crosswalks that we're doing in both cities. The traditional is to come straight across with your sidewalk, but we brought our crosswalks out to the corner, which has some benefits. It makes people a little more visible from vehicles in either direction. It also keeps people from running straight out into the crosswalk. You know, you're diverted a little bit. So we expect people to slow down a little bit before they make their crossing. And this is that arrangement, same arrangement in Bloomfield, you can see. And the bump outs greatly reduce the crossing distance. So this is a plan of downtown Bloomfield, Washington Street. It's 75 feet to cross right now. And with our bump out in the middle here, we go from 75 to 50. So it's actually not as dramatic as some other parts of this street because we don't have a bump out on both sides. In some places, we reduce it to 24 feet. We still have to accommodate the needs of vehicles. There's a really odd center aisle parking in Bloomfield. So this is showing how that skews the traffic patterns. So making streets safer for vehicles is important too, and introducing traffic calming measures. So the porous unit paving serves as a traffic calming measure too. This is a cross-section of Bloomfield showing the relationship of the street and the important public space of the county courthouse building. And parking. I'm not going to talk a lot about parking. That's its own presentation, but nobody, business owners never want to see parking reduced. And parking tends to get added over the years. So we're trying not to eliminate too much parking at Bloomfield. For West Union, we pretty much stayed the same. And we did it through consistent stall sizing and more efficient layout of parking. So this is a very inefficient layout of parking in Bloomfield with 2 lanes here and only parallel parking loaded on this side. You actually end up having a lot more paving than you need to serve that many stalls. So that's something to think about. Accessibility was also important for both projects. So this is a graphic of what we intend to do at Bloomfield, and this is a photo of what we actually did at West Union. So little ramps that, you know, these buildings were built before before the sidewalks were really constructed, and they're at various different elevations. So for some of them, we had to build these ramps to get wheelchair access into them. This graphic is showing the sidewalk space at Bloomfield and how we're breaking that space down into different use zones. These last few images show kind of the icing on the cake of incorporating local art and craftsmanship, and this is how you preserve and respond to those cultural resources. All of these things were constructed locally. We found local craftsmen. These panels, these etched bronze panels, that's actually the historic photograph of the 1918 street, or 1908 rather. So that's before. Okay, so I've talked a little bit more about stormwater. I think I've talked about the path. Some of the ways we celebrated the role of water in the landscape are through these runnels. These are recycled bricks, and there's a spillway here that's decoratively carved. And then at the ends of the street, kind of to signify gateways, we reconstructed these mounds of stone that reference the limestone canyons found on the Turkey River not far away, and the dry river creek motif, which also helped us to minimize the amount of planting. So you can see we reduced it by about 40% in this planter alone so that they could maintain all of them. Another thing that I'll just mention and end here is how we're really, how history repeats itself. I guess that's the tagline I would say. The photo I was showing before of 1908 was just about 10 years, or I guess 1914 is when they paved the street. So 6 years before they paved the streets for the first time in West Union. And they used these huge, beautiful purple-red bricks. And we knew they were still there. They were actually under, so this is just before the street was paved. This is about 1908. It was all dirt. And the sidewalks, I believe, were boardwalks, so they were all wooden. And then this photo is from 1918. And you can begin to see that they've repaved the streets. And that's actually the old courthouse building. It burned in a fire, but that's another story. So the point I'm making is these bricks were still there almost 100 years later, or exactly 100 years later this year. And we weren't sure what condition they were, but when we started demoing, we peeled back the asphalt, and there, almost in perfect condition, was the original brick street. It makes you wonder why they ever paved it over in the first place. We anticipated there would be a lot of them, and so we accommodated reuse of them in our streetscape. And we had the contractor peel these up, clean them off, and then reinstall them. So here they are being staged. And then we use them in the intersections and in the runnels that I showed you earlier. So each intersection has the bricks, and we use spacers in between them to convert the old unit paving technology into a permeable unit paving technology. So water actually drains through these bricks here in the middle. But it's a testament to this type of flexible paving system and how long it can endure and last. And we're hopeful that the other technologies we've installed might last as long. So thank you. It's a big project, and I know I ran through a bunch of different concepts, but I'd be interested in answering any questions anybody has.
What a runnel is? Who's not runnel? Can you hear that, Jason?
I'm sorry, I missed it.
Okay. Rachel is interested in knowing what a runnel is.
Oh, sure. Let me see if I can minimize this. So the runnel, I'll go to a picture that shows it.
He would have to turn his camera on.
Oops, I just passed it. Okay, so the design of the sidewalks at West Union, here on the right, you can see the unit paving. We reused the bricks as a courtesy walk, so we have angled parking here, and as you can see, the cars extend a couple feet past the curb because the bumper hangs over. And we wanted enough room for somebody to get out of their car and walk around these planters. So there's about a 2.5-foot courtesy walk that we created with the recycled bricks, and we fashioned them to have a little bit of a dip in them so that as water runs across the sidewalk, it doesn't immediately flow over the curb. It hits the runnel, and then at every parkway rain garden, it gets diverted into here. To be honest, we haven't seen any water accumulate in these yet because the capacity of the pavers themselves to infiltrate the water into the underlying gravel is so great. But we wanted that to be available for storage during really, really heavy rain events, or if for some reason the sidewalk doesn't get maintained well enough and the joints seal off, the water will be temporarily detained in here and then eventually drain out through the soil. So the runnel is just a conveyance. It's a decorative conveyance. You could also call it a gutter, but you know, that's not as nice a word.
So we have a question from Tara.
Regarding that, you said that the water isn't actually collecting in the island because the pavers take so much water.
So she's noting that since water isn't collecting there because the pavers take so much water, then
does it mean you have to irrigate more than you anticipated?
Does it mean you have to irrigate more than you anticipated?
That's a really good question. The answer is yes. The soils are, because they're so porous, they are pretty dry conditions. The plants that we chose were all pretty drought tolerant, and the addition of the leaf compost does mean that we retain pretty good soil moisture. But it's true, they do tend to dry out, and so it's the counterintuitive notion of a rain garden is really a dry environment. If you want that water to move through and evacuate the rain garden, which you do if you need it for stormwater purposes. So yes, we do anticipate slightly more watering. We're fortunate that we have had several really gentle summers in terms of weather, temperature, and rainfall over the last 2 years. This past year particularly was maybe one of the most ideal summers we've had in a long time. So far we haven't had a big drought, but that will be an issue.
Can you tell us what your soil recipe is for the planters?
Closely guarded secret. No, I'm kidding. Yeah, no, it's not closely guarded. It's 2/3 sand and 1/3 leaf compost, partially decomposed leaf compost, and that's by weight. We've tried various other combinations. We had a performance specification that we used for a while. So a performance specification basically says we don't care what you use, but this is how it has to perform. And it was literally a written document that says it needs to have no more than 10% clay. It has to have a minimum of 10% organic matter. The soluble salts have to be such and such, and the pH has to be between, and we still have specifications for the leaf compost and the sand. But the problem was we would permit any combination of local soils and sands to meet the specification, and then in construction, we would go through, months of back and forth testing and to get the right combination of topsoil. And like at the Biorenewables project, we just realized that the topsoil was too unpredictable, and since then we've gotten rid of it. And this blend of sand and compost works great, and our only concern is long term, how long it will sustain, because the compost is pretty volatile in terms of how quickly it's going to decompose. But with the type of plantings we put in, we're hopeful that we can maintain the organic content of the soils.
So I have a question, which is, how did you decide how much water to store? Did you just go for the maximum amount, or did you have a metric you were trying to meet?
Yeah, that's a good question. We set our own metrics. Give me a second. I'm going to see if I can pull it up. Tom Price helped develop that for us. And
The civil engineer?
yes. I have, you don't want that.
Do you see how he was able to go back through his correspondence file and find us? You have to have a filing system.
Yeah, that's true. Yeah, we wanted to drop certain events, so a 2-year 24-hour rainfall event and a 100-year event below a historic assumed pre-developed rate for runoff. So you can see from this table, and I'm kind of reading as I'm looking at it. There was the 2-year Q stands for 2-year quantity and 2-year velocity, I believe. And well, this is quantity and rate because that's cubic feet per second. So basically, there were target rain events that we wanted to return to the pre-developed condition. The actual performance is probably much greater than these goals. We took 100% impervious area and converted it to 100%. I'm sorry, 100% impervious area and converted it to 100% pervious area, and then have a large amount of storage for it. So the ratio of storage volume to the area we were collecting from was much bigger than we normally have on a project, because they were one and the same. Our storage area, our collection area was the storage area, so it was a 1-to-1. If that makes sense.
Uh-huh.
So we didn't even really, we set our own goals for this because we were so far off the chart.
So if you,
But
looking at what it is now and how xeric it is, would you trade some of that water storage for rooting volume so you could have shade, for example, or?
yeah, I do think that would be a better trade-off in the future. And I mentioned we didn't introduce structural soils, and I've used structural soils, and I can't exactly remember why. And this goes back to, I should have a decision-making structure here to say why we ruled it out. and I don't have one here. I do know that the care of the plantings was a big concern, and just the quantity of plants, and that would have to be weeded and watered was a big concern. So we ended up reducing the surface soil volume for that reason. But certainly I think there's probably room for introducing structural soils along with the regular gravel beneath the permeable surfaces. And we're looking at that right now for Bloomfield. One of the things I really like structural soils for is not as the primary rooting environment, but as a way to connect isolated plantings with larger areas of green space.
Do you have
So
an
it's,
example
root
of that?
path. Yeah, we're doing it in Bloomfield, and I don't have a picture of it, but I'll show you where that will be. So, oh shoot. Here. So here's downtown Bloomfield. This is an earlier conceptual plan, but we've got these tree plantings along the inside of the courthouse square. We're adding a 10-foot wide permeable paving sidewalk here. There's no sidewalk there now, and we want street trees, and we want to connect them to all of this lawn space here. So we're looking at a detail for next to each tree grate. It'll be some type of tree planting pit. It's not going to serve bioretention. It's just going to be for the tree. And it may have a tree grate over it, or it may be an open planter. But in either case, we're looking at connecting it to the lawn by using the structural soils under the permeable paving that's separating it. There are other, root paths. I've never used root paths, but the little channels that open up a void for tree roots to climb through. We kind of suspect that some of this is going to happen anyway in the open graded stone under the unit paving, and that may be why we didn't employ them at West Union. The tree roots will find their way through the fabric that separates the gravel, and there will be ample pore space in that gravel for the tree roots to move around in. It's just the nutrients that the structural soil have with the kind of the muddy gravel that is Cornell soil. We don't have that. So.
Rachel has a question.
But I've seen some the great soil debates going on, and I know enough to know that I don't know enough. You know what I mean?
We've been focusing a lot on soils, so we have a class of whiz kids here if you're interested.
Oh, maybe you guys can help me.
Well, they know how to do the calcs. In fact, they could probably do the calcs on your trees that we're looking at here. Tell you how much tree you can have for the amount of and based
soil.
on your mix. Yeah.
Yeah.
I told them all my secrets from back in the day.
Well, the street it's a tough place for trees, and I'd like to think we could have all 80 trees that we're showing here. The reality is we'll probably end up backing off and having fewer, and making sure that where we do put them, we can support them with soil, and we'll see.
So I've got two questions from the audience.
One is, why are the diagonal crosswalks like wonky, like rhombuses or something?
So Rachel was asking about why the rhombus again. Is that for visibility primarily?
Well, I think she's identifying that they're not, they're not a square. They're not straight, and I'm glad it bugs her because it's bugging me too. But I'll tell you why they are that way, and that's because when you come down here, our sidewalk along Franklin Street here is 16 feet wide. It's bumped out, and actually the existing condition, the lanes are even further out So there's a greater skew currently, and we're reducing that, but there still is a skew through here. So there's a change in, there's a skew through the intersection. And that plays itself out in the crosswalks. And we tossed around alternatives for squaring this up, but when you do that, you don't meet the walk at the corner, and you end up with the geometry wasn't working, and so it's just if we pursue this design, we have to accept, and by this design I mean these principles. We've got to accept this little rhombus thing, and it's all tied back to the fact that the streets don't go straight through. They're cattywampus.
Okay.
I do think in 3 dimensions when you walk the street, it's not as evident, and this was true for West Union. We had other features like this that in plan look greatly askew, and then when you get down on the street level, it's because of your changed perspective, it's actually not as bad.
Okay,
So
she has one more
that's an awful
question.
response.
You had mid-block crosswalks. How far apart are those?
She's asking how far apart are the mid-walk crosswalks? You mean from the corners? Or
Well,
Here-
just how far apart are the crosswalks from each other?
from there to there?
Yeah.
So she's saying how far is it from the mid-walk crosswalk to the corner?
These are 300-foot blocks, I believe. So it's about 150 feet, a little more, probably about 160 feet from there to there.
And is that as much about traffic calming and making the courthouse lawn more of a park?
Yes, there are already sidewalks to the courthouse that line up here and here. And so it's to connect. When you have a mid-block crossing, for one, our speeds here are 25 miles an hour, so that's important to note. We expect traffic to be going pretty slow. A mid-block crossing, though, a pedestrian only has to track traffic going in 2 directions. You just have to look left and right. Corner crossings are actually a lot more hazardous inherently because you're tracking traffic coming from 4 directions. So the DOT, surprisingly, and this is why I said it was kind of nice working with them, because they are very supportive of this mid-block crossing. The other thing we're doing, though, in Bloomfield is a lane reduction of 4 lanes to 3 with a center turn lane through here. And they're also supportive of that, the DOT. We do have some local pushback on that idea, so we'll have to see where that one goes. But the mid-block crossings also are a traffic calming measure, as is the parking itself.
Other soil tree design questions? Do you see other options here you want to ask about? Jason, have you guys talked to James Urban about the suspended pavement system at all on some of these?
With the supportive cubes, the stacked? Yeah, we have, and he's been in, and we've talked to him about that system. And I understand the basics of it. That we've got the stackable HDPE crates, and you fill that with soil material. My concern is settling over time of the soil and the ability to get through the paving to replenish that soil material, because you want to have a certain amount of organic material, and organic material oxidizes over time, and if you don't have plants contributing leaf matter and debris back into that soil, you're going to see settling. So I guess I don't and that's probably the case with any, hidden soil. I think the advantage that something like structural soil or Cornell soil has is you don't have a lot of organic matter. I mean, your nutrients are mostly tied up in the clays and the silts, and it's organic low. So you're not going to have oxidation in there. So for that reason, I'm not sold on the crate system. I see gravel. If you want support, I see the open graded gravel as more feasible and more locally sourced, and it's not relying on a plastic. So I like gravel. I'm a gravel guy.
Okay. And your water storage metrics on this, are they similar goals to the West Union goal? Are you?
Yes.
Okay.
They will be the same. We are also collecting runoff from the courthouse square here too, so we've got some off-site sources. But they'll be very similar.
So you're collecting water that runs off from the lawn of the courthouse that's in the middle of this image?
Yes, and the roof. So in this design, right now, and right now they're having a lot of flooding problems with the building, and it's primarily due to the fact that the roof drains, which are externally plumbed, they're downspouts, they discharge water right at the foundation. So our plan is to connect those up and send them out away from the building to our bioretention and have them daylight in the bioretention bump outs. So that way the water gets filtered through the soil and the plant material, and then eventually gets stored in the gravel under the streets. But then the lawn area right next to the sidewalk here will have engineered soils, and it won't look like traditional bioretention. We're not introducing a lot of vegetation other than maintaining the turf grass lawn, but the soils that the turf grass will be in will be that same engineered mix, and the gravel will be connected to it. So we're wanting to keep the lawn from going directly on, the water from the lawn from going directly onto our unit paving, because it carries grass clippings and debris and can clog our gravel. And so for that reason, we've got a cross section. I think I might be able to show it to you. Up here. So it's a type of it's basically bioretention. Won't have the benefits of, here we go. Won't have the benefits of the heavy vegetation. You see it over here. It's a very shallow depression. But our runoff rates aren't that high, and so we don't really need much more than consider this to be like an interceptor.
I see.
Because the roof will be drained directly to these areas.
So that's a sand structural soil?
Correct. Well, it's just I wouldn't consider it to be a structural soil because we're not carrying anything on top of it. It's just a sand-based engineered bioretention soil.
Okay. Other questions? Okay, I have one more from Tara.
Great.
What kind of trees did you use in the street?
What, did you hear that? What trees are you
What kind of trees?
considering? Yeah.
Well, I am a tree lover. I love trees. And I found that there are a lot of us out there, but we all love different kinds of trees. And West Union didn't want trees at all. And the story they related to me was they chopped them all down about 40 years ago because they had birds nesting in them. And they didn't like the nuisance that the birds presented. And so I don't know what kind of birds they had. And
They were
was
probably
foolish enough
crows.
to Probably. And I was foolish enough to get into a debate about habitat and why that was a good thing and not a bad thing. And but ultimately we did end up having trees. Because of the porous pavement, though, we do have to be careful the types of trees we plant, because small-leaved trees like honey locusts can clog the paving quicker. So, you know, we want trees that are adapted to the soil, so trees that are pretty hardy, so the typical kinds of street trees that you might plant, but also ones that don't drop a lot of small leaves or small fruits and nuts. You know, we relied on a mix. We did use several species of oaks, silver lindens, which I really like, are really hardy, nice big tree. Some non-natives. Silver linden is actually a non-native, but like ginkgo at West Union, I believe we used in a few places. Some smaller trees where the planters were smaller. So hardy trees. It's going to be a pretty, even with the efforts we made, a pretty inhospitable environment. There's a lot of things that happen in a street, so we wanted to be realistic.
So are you looking at Turkish filbert or any of those super drought tolerant?
I have not used Turkish filbert. I should give it a thought. I could pull up our tree list. Hold on. I'll tell you exactly since we're talking about it. There we go. Oh, that's it. Yeah, here you go. So, for your consideration, here's our tree list. So the Armstrong, the hybrid maple, that's a hybrid between red and
Silver, right?
And silver, yeah, it's a very hardy maple. We also used a cultivar of red maple, Celtis occidentalis, so the hackberry, it's one of my favorite street trees. It's very tough. Australia, also a pretty tough guy, drought tolerant. The shingle oak, there's the silver linden. And I did test out some of the disease-resistant elm cultivars. So I forget which one we actually went with. I list a few here. So 5 of those. And then some smaller trees, serviceberry, a crab. I generally never use crabs, but I think we decided to here. And then this was a weeping cherry for a memorial that was there, and we let the patron pick that tree. And then tree lilac is also a small tree I really like for streetscape environments.